Hello everyone, welcome back to the session. In today's class, we are going to talk about a very important concept in Terraform, Terraform providers and how they talk to cloud APIs. Okay, along with that, we will also understand what Terraform unit actually does and what the .terraform directory is and what the terraform.log.html file is and why it is important. Okay. By the end of this session, you will clearly know how Terraform connects to that AWS or Azure or GCP Kubernetes and how the initialization process works behind the scenes. Okay, so let you have to go the previous video so that you can go through the Terraform problem with Terraform and how I see with Terraform solve these issues and all, and how we can install the tools, different tools and basic commands already we have discussed. Okay, I already discussed so many things like dependency, like implicit dependency, explicit dependency. Okay, and we have also seen that core building blocks of Terraform language and all. So we also seen that some top level of blocks. So again, I am starting from that Terraform providers. Okay, so Terraform providers. Okay, listen carefully so that these are the basic thing. Okay, if you will understand the basic part so that you can able to go into the deep of Terraform. Okay, yeah. So what are the Terraform providers? So let's start with the basic questions. What is a provider in Terraform? Terraform itself is just a tool. It does not know how to create an EC2 instance or an Azure virtual machines or a Kubernetes pod by default. To talk to different platform, Terraform uses providers. Okay, so I'll write here so that you can understand. Okay, to talk to the different platform, Terraform uses providers. And you can think of a provider as a plugin that knows how to talk to a specific cloud or service, which APIs to call, and how to create, update, or delete resources on the platform. Okay, so whenever we writing something like that resource one, here we have already seen that the yeah, this one. If I'll say, if I am writing this thing, so how Terraform recognizing it and how Terraform understand it. Terraform uses the particular provider internally and that talks to that API, particular cloud API, to actually create that resource. Like here, okay. So Terraform uses here, that Azure provider internally, and the Azure provider talks to that Azure APIs to actually create that resource group, okay, as a resource. So I already explained you that things. Now providers and the cloud APIs. what we have. Each provider is tightly integrated with platform APIs. The AWS provider talks to the AWS APIs like EC2, S3, IAM, Lambda, etc. The Azure provider talks to the Azure REST APIs, okay, and the Google provider talks to the Google Cloud APIs, and the Kubernetes provider talks to the Kubernetes API servers, and many more clouds, having their own provider to talk to their particular API server and all. Okay, so real flow behind the scene is like that. I'll show you. Yeah, if I am writing this as a configuration code, so this Terraform code, okay, Terraform provider, it goes to the Terraform provider, then it goes to the cloud or that SaaS API, and then it, actual resource is created. That is why providers are so important in Terraform. Okay, so common cloud providers, if you can see, we already seen that. Again, we can see if I'll go to Terraform registry. Yeah, yeah, you can see AWS, Azure, GCP, Kubernetes, Alibaba Cloud, Oracle Cloud. Okay, so these are the common cloud providers we can say. I'll write here so that you can understand it very easily. Yeah, common cloud providers we have. I'll write here. We have AWS. Okay, we have Azure. We have GCP. We have Oracle. We have Kubernetes. So we'll see the each provider, each cloud provider, so that we can understand it. Yeah. I'll talk about that AWS provider. Okay. So quickly go through the some common providers that we use in real projects. So we will focus on that first Azure, then AWS, then GCP, then Kubernetes, then Oracle. Like that we will go. So first to understand that in AWS, if I'll go there, the AWS provider uses AWS APIs like EC2 for virtual machines, okay, S3 for storage, IAM for users or roles, Lambda for serverless, and so on. Lots of resources is there. So I'll write here so that you can understand it. I'll copy it from the Terraform registry. This is the AWS provider. If I'll see the Azure, and if I'll talk about that things like APIs and all, okay. So we have, let's take together so that you can understand it. Okay, so EC2 for virtual machine, S3 for storage, and IAM for user roles, like that we have. Okay, and if I'll talk about that authentication is usually done by that access key and secret key, or we have IAM role for EC2, ECS, etc. Or we have environmental variables like AWS access key ID and AWS secret access key, like that we have. So we will discuss it later and in detail. Okay, so I have given that like that only. And here we are telling Terraform that use the AWS provider and work in the that, if want to say that use US East one, so that we can write the location also here. I'll write it here only so that region equal to that US East one. Yeah, like that we can give means use the AWS provider and work in the that US East one region, like that I am telling about this provider, AWS provider. Okay, now we have Azure one. Okay, so Azure one we already have seen that. Let I'll delete this blank one. Yeah, we already have seen so many times this Azure provider. Okay, and we have in the Azure provider uses that Azure REST APIs to manage the virtual machine, storage account, virtual network, and more. And the authentication is typically done using that service principal. We can say that as a appreciation or managed identity. Okay, when running from an Azure resources. So these are the things. In in real project, along with these, we usually configure environment variables like ARM client ID, ARM client secret, tenant ID, subscription ID. Okay, these are used by the providers to authenticate to Azure only, like that we have. Okay, Let I'll copy from here. Yeah, we have virtual machine. We directly call here virtual machine. I already gave you idea. Already given idea. Okay. Virtual networks. Azure. I'll write in short form. Okay. AKS. Azure Kubernetes services. Okay. If I'll next we have that GCP, Google Cloud Provider. Okay. Yeah. Now the GCP. Come to the GCP. And the Google provider uses Google Cloud APIs to manage. Like we have there as a resource as a compute engine, cloud storage, GKE for Kubernetes and others. So authentication is done using a service account JSON key. Okay. So if I'll take the code for GCP, yeah. Yeah. So this is the provider of GCP, and here the provider needs the project ID, the region, and access to the service account JSON for authentication. Okay. Now if I'll take Kubernetes, we have compute engine, we have cloud storage, we have GKE. Okay, for Kubernetes. And now come to the Kubernetes. So Kubernetes provider, the Kubernetes provider talks to the Kubernetes API server to manage. Like it have pods, deployments. Okay, so I'll write here we have pods, we have deployments, we have services, we have config map, and so on. Okay. And authentication generally done using your kubeconfig file. Kubernetes having one kubeconfig file. Okay. We will see it when we will go through that Kubernetes, so you can understand it very easily. I'll take the provider sample code for you guys. Okay. Now come to the, yeah. This tells Terraform that use the Kubernetes cluster that is configured in my local kubeconfig, like that we can say. And let's take the code of Oracle from Terraform registry, that is OCI. Okay, this is the sample code. If I'll talk about that, some resources of that, cloud and all. So we have virtual cloud network. Okay. We can see here Oracle. Yeah, let's copy it from here. We have virtual cloud network instances. API gateways. Okay, and so on. Yeah. So these are the cloud common cloud providers. Okay, now come to that. You know, yeah. Now that come to that. What does Terraform init do? Okay, what does Terraform init do? So we have uh, what does Terraform init do? Most conceptual questions. Okay, if you understand this, means 20% part you have understand it. Okay, so you have to be careful while writing learning this Terraform neat one. Okay, so so very important command, that is Terraform init. Whenever you start working with Terraform in a new folder, the very first command you should run is Terraform init. Okay, what that command is? Terraform init. I'll write this so you can understand it very easily. Whenever you, yeah, I'll write this full one. That is Terraform init. Yeah, but what actually happened behind the scenes? Let's break it down. Okay, one by one. So first, it first thing it do as a it downloads the provider. Okay, download providers. Terraform looks at your configuration and checks which provider are you using. For example, AWS, Azure RM, Google, Kubernetes, etc. Then it downloads those provider plugins from the Terraform registry and stores them locally in a folder called .terraform. Okay, so through that I'll show you practically so that you can understand it. Already I have showed you, but again, while I am going through this topic, so I'll let you know. Yeah, if we'll go by this class regularly, at the end you can able to write the Terraform configuration file like this. You know, I'll show you how Terraform code look like. Yeah, this is the module file structure, and this is the simple command for resource group. You can see here. I have used as for each one, and if you can see the variables here, this is the generic code for resource group. You can use it multiple times for any project, for any client. Okay, if I'll show you some more Terraform command, vnet. Look, this is the code. Okay, for a vnet virtual network. I have used here dynamic block. I have used for each. Okay, in each command. This code is generic code. Okay, whatever the argument it have in Terraform registry, I have given all the things. The customer or client, according to their uses, we can use it. If you see the variables, yeah, in each variable I have used that map of object. Okay, you can see by the end of this session and all, you can able to write this type of code. If we'll see the virtual machines code. Okay, let's see. If you go through the basic command, you can able to write this code easily. Okay, in easy manner you can write. This is the virtual machines code. Okay, if you see the public IP code, this is the public IP code. What I have done, just I have went through that, Terraform registry only, and I have that all the things. Okay, like if I'll see which code we are looking into, that is public IP. I'll show you here. Terraform public IP Azure RM. Yeah, if you can see all the arguments. Okay, all the arguments what it have in this bucket. Okay, so I have all the arguments: name, resource group name, location, allocation method, which have optional also. Na, we have taken into that part: DDoS production mode, domain name label. So which client having requirement on that, we can use that. If we have kept at optional. Okay, yeah, like that we have kept optional. These are the optional we can use or we cannot use, depends on the uses. Okay, yeah, here we can also see that we have kept the variable in option mode, so you can write it very good manner while you are going through this full session. At the end of this session, not this session, means the entire, whatever the program I have for 20 days or 15 days or 25 days. Okay, it depends. Yeah, so I'll show you. Yeah, here only. Yeah, you can see what we were into. Uh, yeah, download providers. Okay, let's see. Let's remove this Terraform backend, and I'll write here my subscription ID, agent account. So I'm not going to use this Copilot right now. So yeah, this is my subscription ID, and I need to give it here. Okay, so now you can see that what happens when I run this Terraform init command. Okay, provider plugin and all. So what it does, download the providers. So Terraform, I told you that it create .terraform directory. You can see here. Okay, so if you are using the AWS and Azure providers, Terraform init will reach out to the registry and download the correct version of those providers and save them for this project. Okay, so you can see it here. I'll write it here so that you try to make the notes, so that guys, it will help you a lot. Okay. Okay, download providers. Now come to the second point, that is configure the backend. Configure the backend. Okay, so if you have configured a backend like local S3 Azure storage or any any GCS, so Terraform init will also initialize the backend so that Terraform knows where to store the state file. Okay, here if you can see, I'll write it here. Terraform init will also initialize the backend so that Terraform knows where to store the state file. Okay, if you'll see here in VS Code, we have not mentioned that the backend block here. It comes under the Terraform block, and we can see that no backend block is configured right now. Okay, so here what will happen? Our Terraform state file will be in our local only. Okay, while we run our Terraform plan or Terraform apply. Okay, let Terraform plan. Okay, now you can see terraform.tf state file. So it should be in your local or S3 or Azure storage and all. So after that Terraform init will do this work. Okay, like you can see, while I have run that Terraform init command here, it started the initializing the backend, and it did not get any backend block here. So my Terraform knows that I have to keep my state file in local only. Okay, like that. Now come to the third one, download modules. Okay, if you have any modules, so it download the modules. Okay, third, download modules. So if your Terraform configuration uses any external modules, you know, I'll show you some example for modules. Yeah, this is the module block. From this we can Okay, so Terraform init will download those modules as well. So after Terraform init, all modules and providers required by your code are ready only. Okay. Okay. And it's you know one more thing it does, and that is the prepares the working directory. What it does, prepares the working directory. Working directory. Okay, in short, I can say Terraform init prepares your working directory so that you can safely run Terraform plan and Terraform apply. Okay. I'll write here so that you can understand it. If interviewer will ask you that what Terraform init do, so you can explain it very easily now. Terraform plan and Terraform apply. Okay, so these are the things Terraform init do. Now, what is that dot Terraform directory? Okay, what is that Terraform directory? What is the dot Terraform directory? So after running Terraform init, you have seen here that .terraform directory has created. So Terraform creates a hidden folder called .terraform, and this directory contains your provider binaries, whatever the plugins you downloaded through the Terraform init, the cached modules, and some backend related files. So I'll write here dot Terraform directory. So directory contains, that provider binaries, caches, modules, and some backend related files. So I'll show you a sample structure. I'll show you how it look like, okay, so that you can understand it. Yeah, here we can see Terraform. Inside that we have providers. If we'll see in reality, we can check out here. You can see providers. We have registry.terraform, registry.terraform.io, then Hasikoff, then whatever the provider you have, okay, the version, like that, okay. And if you have modules, cache and all, so it is like that, okay. So why is this useful? It helps Terraform, run faster, okay. Yeah, so why it is useful? I told you that Terraform run faster because it does not have to re-download providers every time. Now, once I have downloaded the providers, okay, so now no need to download it again. If while writing the code for the second resource group, okay, so okay, so now no need to download it again. Means I don't have to run that Terraform init command again. Okay. Once if we added the new modules, then we can run Terraform init. If we have changed our configure backend configure, then we need to run Terraform init. Okay. Else we don't need to run Terraform init again and again. Like that. It happens. Okay. So now I can go for again. I can go directly for Terraform plan because I already ran that Terraform init once before. Okay. So now I can see that two resource is going to add. It will show in my plan. Yeah, now you can see it works. Okay, means no need to again run that command Terraform init again and again. So and it keeps all project specific provider versions in a single place. Okay, whatever that it have, it is keeping all the project specific provider version in single place. Okay, usually we do not commit that .terraform directly to the version control. Okay, like Git. while we I'll show you that while we are pushing our code to any git repository and all, so we are not pushing that .terraform directory to version control. We just keep it in git ignore so that it not go to that particular repository. Okay, so only the configuration file .tf and log file are committed. Okay, so what is other that log.html? What is that Terraform dot log dot HCL? So another important file that gets created after Terraform init is terraform dot log dot HCL, and we can see it here dot terraform dot log dot HCL. Okay, so we can see there are so many things inside that. So why it is created? Let I'll discuss. So this is an auto-generated log file. Okay, and its main purpose is to lock the provider version, so that Terraform always uses the same version of each provider, and we avoid accidental upgrades that might break our infrastructure. So this is very important in teams and production environments. Okay, so we can see here, if I'll copy the things from here. Okay, it is already written that this file is I'll show you. I'll let you make it bigger so that you can understand it. Yeah, this file is maintained automatically by Terraform init, and manual edits may be lost in future updates. Okay, it may be broken like that. It happens. Okay, so I'll its main purpose is to I'll write it so that you can remember it very easily. Terraform always uses the same version for each provider. Okay, and we have another point that so we avoid accidental upgrades and all. So we having this file. Okay, so you can answer to interviewer if they ask like that. So here we can see that 4.54.0. Okay, so it means that Terraform is locked to that Azure provider version 4.54.0. Okay, and hashes are are used to verify the integrity of the download provider binary. These are the hashes you can see. And so even if a new version of the Azure provider is released tomorrow, your project will still use that particular version 4.54.0 until you explicitly upgrade it. Okay, so this file is very important for Terraform. Okay, so this makes your deployment stable and predictable. and we normally commit terraform.log.html to Git so that everyone in the team can use the same provider version and get consistent behavior across machines. Okay, so we are pushing this terraform.log.html so that everyone means all the team members can get the same kind of version. So we can have a quick recap today. So let's quickly recap what we learned in this session. So we have seen that Terraform providers. So providers are plugins that allow Terraform to talk to different platforms like AWS, Azure, GCP, and Kubernetes, Oracle, and whatever the cloud it is. Okay, and they internally use the cloud provider APIs to create, update, and delete the resources. Okay, and we have common providers. We have seen that AWS we have seen. Okay, we seen that Azure, GCP, and that AWS. I already told you that AWS uses AWS APIs for EC2, S3, IAM, etc. Azure uses that Azure REST APIs for virtual machines, virtual network. Okay, subnet. GCP uses that Google Cloud APIs. Kubernetes provider talks to the Kubernetes API server. So each provider has its own authentication mechanism like access key, service principal, or kubeconfig. And we have seen that Terraform init. What Terraform init do? It downloads the required providers, initializing the backend, download modules, and it make a prepare the working directory for plan and apply. And we also seen that .terraform directory. What it does, it stores the providers, modules, and the backend info created after the Terraform init. Okay, created after the Terraform init only. And we have seen that terraform.log.html. Okay, so logs the provider version what we have and ensure consistent and the safe deployment across environments and team members. So that's all for this session on Terraform providers and the API details and how Terraform init, .terraform and terraform.log.html fit into the picture. In the next session, we can go deeper. Okay, whatever we have. If you found this helpful, don't forget to like the video, subscribe the channel, and drop your questions if you have in comment box. Okay, thank you so much for joining and see you in the next session. Okay, thank you guys.